Hello friends and my dear students, I welcome you all to my channel. I hope you are all well and your studies are also going on well. This is set 3 of 5 good problems on the chapter of polygons where I will solve relatively harder problems. If you have not watched the set 1 and set 2 videos of 5 good problems, then I strongly suggest and request that you please watch those 2 videos as well to have a good practice of relatively harder problems on the chapter of polygons. This video is part of the playlist Maths 8 Hot. Hot HOT stands for High Order Thinking, where I solve relatively harder problems, 5 good problems every set from a chapter as and when it is completed in the other playlist, that is CBSE Maths 8 RS Agarwal. If you are new to my channel or not yet subscribed, and if you are watching my videos regularly and my videos are beneficial to you, then I strongly suggest and request that you please support me by subscribing to my channel, and do not forget to press the bell icon so that you will be notified by my future videos. So let's get started in solving 5 good problems of set 3 on the chapter of polygons. Okay, so I have the I have the set of 5 good problems on the left hand side of set 3. I hope the fonts are big enough so that you can see them properly. The PDF version of these 5 good problems will also be there in the link of the PDF will also be there in the description below. On the right hand side, I will solve the problems. After solving a problem, I will pause for a few seconds so that you can take a screenshot of the solution if you think it will help you. Let's start solving the problem. Question number 1 says, for an n-sided polygon P, if E and I are the sum of the exterior angles and the sum of the interior angles, then which of the following is necessarily true if E is to I, that is ratio of E and I is 1 is to m for some natural number m. Okay, so what is E? P is a n-sided polygon. P is n-sided polygon. So let's write down all the given information. P is n-sided. It is not a regular polygon but a normal. It could be a regular polygon or irregular polygon. It's a normal polygon. P is n-sided polygon. Okay. And what is there? E is the sum of exterior angles. Sum of exterior angles. I is given to be sum of interior angles. Okay, now the sum of exterior angles of a polygon of n side, we know it is always 360 degree irrespective of n, that is for any number of sides. Polygon, for a polygon, the sum of the exterior angles is always 360 degree. Okay, and the sum of the interior angles for a polygon of n side is equal to 180 degree multiplied by n minus 2. Okay, this we know from the formula. Now it is given that the ratio of E is to I, the ratio of E and I, that is E is to I, is given as 1 is to m, where m is a natural number. M is a natural number. Natural number means these are the counting numbers, that is 1, 2, 3, 4, 5, 6. So from this given ratio we can say what is E is to I. E is to I will be 360 degree is divided by 180 degree, n minus 2 will be equal to 1 by m. Okay, now if you simplify the LHS, 180 degree will cancel 360 degree with 2. So we have 2 by n minus 2 is equal to 1 by m. So this implies that if we further simplify the left hand side LHS, that is if we can rewrite it as 1 by n minus 2 by 2 will be equal to 1 by m. Okay, now further simplifying the denominator of the LHS, we get it is n by 2 minus 1 is equal to 1 by m. Now we need to come, since m is on the right hand side, m is a natural number. So that means that since m is a natural number, this will imply that the denominator of the left hand side, n by 2 minus 1, must also be a natural number. Of course, from here we can say that n by 2 minus 1 is equal to m. Okay, and okay, let's see. Okay, so we have this. I was trying to solve it in a different way, but I think there is a better way. So we have, now from this we can have this on the left, from the fact that 1 by n by 1 by, so from this equation, this equation, we can always say, since both the LHS and RHS are of the form 1 by some number, where the denominators are is a natural number, since the right hand side m is a natural number, so the denominator of the LHS must also be a natural number, and of course we can say that both the denominator has to be same, because both the LHS and RHS are of the form 1 by n. So we get n by 2 minus 1 is equal to m. From here we get that n by 2 is equal to m plus 1. This implies if you multiply both sides by 2, we get n is equal to twice of m plus 1. N is equal to twice of m plus 1. Now we don't know what is m. M is a natural number. M is a natural number. Now, so what can the value of n be? So this implies n has to be a even number, because 2 into, from here we can easily say that n is even, because why? Because because 2 into m plus 1 is even. Any number of the form, any number which has a factor of 2, any natural number which has a factor 2 must always be an even number, because it will always be divisible by 2. So twice of m plus 1 is always a even number, which means that n is even, n has to be even. Okay, so now what are the choices? Choice A, n is odd, it cannot be, A is false. B is even, that is right. Now C is, says n is a multiple of 3. No, n need not be a multiple of 3. Now a multiple of 3 means that 9 is a multiple of 3, but 9 is not even. N has to be even, that is a must. N has to be even. So C is not correct, and D, n equals to 4. Now n equals to 4, 4 is even, but not necessarily n has to be 4. N can be 6. N can be any even number, but remember that n is the number of side of a polygon, and the number of side of a polygon is the minimum value of the number of side of a polygon is 3. So definitely n is a even number greater than equal to 3, which means that n is an even number greater than equal to 4. It can be any even number greater than equals to 4, but not necessarily n is equal to 4. So clearly the choice is n is even is the correct choice. N is even is the correct choice, because we know that since n is the number of side of a polygon, it will anyway be greater than equal to 3, greater than equal to 3. And so now if any number, any value of n which is greater than equal to 3, and an even number has to be greater than equals to 4 and even. So the choice, so B is the correct choice. Okay. let's do problem number 2. There is a figure. Okay, so in this figure, polygon P1 is a square. I'm not drawing the figure. I hope you can relate my solution with the figure in the PDF. In this figure, polygon P1 is a square, P2 is a regular pentagon. So we can say that let's say n of P1, the n means the number of sides of P1 is equal to 4. Since P1 is a square, and n of, that is the number of sides of P2, P2 is a regular pentagon, so it will be 5, and n of P3 is a hexagon, regular hexagon, so n will be 6. Okay, then the value of x is, I'm just drawing the partial diagram. So we are having kind of this and this. So this is x degree. We have to find this angle. Now let's say we mark the points, vertices AB, ABC, and we have this kind of scenario. Okay, let me draw the full figure. At least I'm not drawing the square, but so my definitely the polygons are not looking regular, but please assume that they are regular polygons. Okay. Now just notice one thing. This side, let's say this be D. CD is common side of, so this was polygon P2, this was polygon P3, common side of P2 and P3. This will imply that sides of P2, this will imply that the length of each side of P2 is equal to the length of each side of P3. Since P2 and P3 are regular, P2 and P3 are regular, which means all the sides of P2 are of equal length, and all the sides of P3 are of equal length. And also CD is their common side. CD is a common side of both the polygons P2 and P3. This will clearly say that side length of P2 is equal to side length of P3. That is, the length of each side of P2 is equal to the length of each sides of P3. This implies we can say AC is equal to BC. AC is equal to BC. Okay. Now AC is equal to BC. This will imply that in triangle ABC, since ABC will become an isosceles triangle since two sides are equal, AC and BC. So therefore we can say that the opposite angles will also be equal. That is, angle ABC will be equal to angle CAB. So this will also be x degree, equal to x degree. Okay. So now how do we find x? We need to find somehow, if we can know the value of this angle, that is angle ACB, then we can clearly find the value of x using the angle sum property of a triangle. The sum of three angles of a triangle is 180 degree. Okay, so we must find angle ACB. Okay, for that we need to find, okay, now let's see that since P2 is a regular polygon, P2 is a regular polygon of side 5, we can say that angle ACD will be equal to an interior angle. ACD is an interior angle of the pentagon, regular pentagon P2. So its value will be 360, not 360. Its value will be, we know the formula that each interior angle of a regular n-sided polygon is 180 n minus 2 divided by n. So we have for P2 n is 5 minus 2 divided by 5. This is the measure of each interior angle of the regular polygon P2, where P2 is a regular pentagon. So this will be equal to 5, 3, 15, 6 multiplied by 3. This is 108 degree. This is degree. So 108 degree. So we have this angle as 108 degree. We also now need to find what is this angle. This angle. We need to find this angle, which is an interior angle of the regular hexagon P3. So angle BCD will be equal to, using the formula of each interior angle of a regular polygon, it will be 180 degree multiplied by P3 is the regular hexagon, so n will be 6, 6 minus 2 divided by 6. Okay, so this is equal to 30 degree multiplied by 4, which is 120 degree. Okay, so this is angle BCD is 120 degree, or each interior angle of the regular hexagon P3 is 120 degree. Now notice that the angle ACB plus 108 degree plus 120 degree must be equal to 360 degree. Why? These three angles are angles around a point. If we consider that the common point of the side AC, BC and CD, okay, so the point is C. So angle 108 degree, 120 degree and the angle ACB are all angles around the point C, and we know that the sum of all angles around the point is always 360 degree. So we have this. Okay, so from here we can easily find out what is the value of angle ACB. This will be 360 degree minus 108 degree minus 120 degree, which is equal to 360 degree minus 228 degree, which is equal to 132 degree is angle ACB. Angle ACB is 132 degree. Okay. Now in triangle ABC, angle ACB plus x degree plus x degree should be equal to 180 degree. That is, the sum of three angles of the triangle ABC must be equal to 180 degree. That is, x plus angle ACB is 180 degree. This implies angle ACB we just found out to be 132 degree. So 132 degree plus 2x degree is equal to 180 degree. If we ignore the degree, we get a linear equation in x, that is 132 plus 2x is equal to 180. This implies 2x is equal to 180 minus 132, which is equal to 48. This implies x is equal to 48 by 2, that is 24. So the angle ABC. So the value of x is 24. The correct choice is A. A is the correct choice. Okay, let's do problem number 3. The interior angles of a pentagon are in the ratio 1 is to 2 is to 2 is to 2 is to 3. Then the measure of the smallest exterior angle is. The measure of the smallest exterior angle is. So it's a pentagon. So n will be equal to 5. Okay. Now the ratio of the interior angles are given. Okay. So let uh, the interior let the interior angles be x degree, 2x degree, 2x degree, 2x degree, and 3x degree. Based on the given ratio, we are assuming that the interior angles of the pentagon are x degree, 2x degree, 2x degree, 2x degree, and 3x degree. Now we know that the sum of interior angles, sum of interior angles for a pentagon, that is n equals to 5, sum of interior angles is equal to, we know, 180 degree multiplied by n minus 2, where n is the number of sides of the polygon. In this case, n is 5 because it is talking about a pentagon. So this implies, now what is the sum of the interior angles based on the assumption? It will be x degree plus 2x degree plus 2x degree plus 2x degree plus 3x degree is equal to 180 degree minus n is 5, 5 minus 2. So this implies, if we simplify all the left hand side terms, x terms, on the left hand side we get 2x, there are 3 2x, that is 6x, and 3x 9x, we get 10x degree is equal to 180 degree multiplied by 3 multiplied by 3, this is equal to 540 degree. If we ignore the degree, we get a linear equation in x, that is 10x is equal to 540. This implies x is equal to 540 divided by 10, which is equal to 54. Now it is asking the measure of the smallest exterior angle. Smallest exterior angle will be the exterior angle where the interior angle is biggest, largest. So one thing you must understand, that smallest exterior angle, we know that an exterior angle and an interior angle, that is, if you have a polygon like this, so this is let's say an interior angle. What is the exterior angle? You extend this side, and so this is exterior angle, and we always have x plus y is equal to 180, that is x degree, the sum of the angles x and y, they are equal to 180 degree because they are linear pair of angles. Now if you want to have smallest value of x, if you make the x as small as possible, the y will increase, y will become as large as possible, and vice versa. If you want to make x as small as possible, then y will be large. So smallest exterior angle implies, it is asking then the measure of the smallest exterior angle. So smallest exterior angle implies largest interior angle. Now what is the largest interior angle? We know we have found x, so the largest interior angle will obviously be 3x. So largest interior angle is equal to 3 multiplied by x. X is 54, this much degree, which is equal to 162 degree. Largest interior angle is 162 degree. Therefore, this implies smallest exterior angle will be we always know that an exterior angle and an interior angle, they are linear pair of angles, so their sum is always 180 degree. So smallest exterior angle will be 180 degree minus 162 degree. This is equal to 18 degree. So the correct choice is B is the correct choice. Okay, let's do problem number 4. Which of the following cannot be the number of diagonals of a n-sided polygon? Okay, so we know that number of diagonals, there is a formula of n-gon polygon. N-gon polygon means a polygon having n number of sides. Number of diagonals of n-gon polygon, the formula is n into n minus 3 divided by 2. Okay. Now, which of the following cannot be the number of diagonals of a n-sided polygon? Now, that means that from the given number of diagonals, we need to check each of the given number of diagonals and see what is the value of n coming. If we know the value of this, so this is the value of number of diagonals for a polygon of n side. If we know the value of the number of diagonals, we can easily find out n. So for each of the given number of diagonals, we need to see if we can find a valid n. Now remember, n is a natural number and obviously it should be greater than equal to 3. So let's try out all the choices. So it is asking which of the following cannot be the number of diagonals. Okay, we have to select the choice where the number of diagonals is invalid. It cannot be a valid number of diagonals. So let's see choice A. So if A says the number of diagonals is 0, this means we must have n into n minus 3 by 2 is equal to 0. This implies n into n minus 3 is equal to 0. This implies this will only be true when n is equal to 3. Now n cannot be 0. Please remember that n is the number of sides of a polygon which is always greater than equal to 3. So in this case, if n can be 3, then the number of diagonals will be 0. So choice A, the number of diagonals 0 is a valid number of diagonals, because for a triangle, we know that for a triangle do not have any diagonals. So the number of diagonals of a triangle is 0. So choice A is not an incorrect choice, it is a correct choice, because for a triangle the number of diagonals is 0. In that case, for a triangle n is equal to 3. Okay, let's see choice B. So if choice B is correct, that is let's see if we can find the value of n such that the number of diagonals is equal to 10. N minus 3 divided by 2 is equal to 10. So this will imply that n into n minus 3 is equal to 20. Now, so the left hand side is n into n minus 3, and both n and n minus 3, they are natural numbers. Now we need to see if we can factorize 20 as with two factors, where each one factor is 3 more than the other factors, because the left hand side is n into n minus 3. So n minus 3 is 3 less than n. Now, can we factorize 20 such that can we factorize 20 as two natural numbers so that their difference is 3? 5 4 5 4, it can be 5 into 4, but the difference of 5 4 is not 3, so this is not possible. 2 10 210, but the difference of 210 is not 3, not possible. What can be? So these are only the two ways we can factorize 20, and clearly we can see that we cannot find n such that we cannot find the value of n such that n into n minus 3 is equal to 20. So definitely at this point we can say the correct choice is B. So you need not check the choices C and D because these are all single correct choice multiple questions. Now for the sake of discussion, let's see if we can find if 20 and 14 are valid number of diagonals. So we must have n into n minus 3 by 2 is equal to 20. So this implies n into n minus 3 is equal to 40. Now let's see how we can factorize 40 so that as two natural numbers, product of two natural numbers, so that the difference is 3. Clearly 8 and 5 is one such factorization, because we know that 8 and 5 is 8 multiplied by 8 minus 3. So 20 is the number of diagonals for when n is equal to 8. So definitely 20 is a valid number of diagonals. Let's check choice D, that is n into n minus 3 by 2. Okay, n into n minus 3 by 2 is has to be 14. So this implies n into n minus 3 is equal to 28, and of course 28 is 7 multiplied by 4, which is equal to 7 multiplied by 7 minus 3. So 14 is a valid number of diagonals. So hence the correct choice is B. 10 cannot be choice B, that is number of diagonals 10. No polygon can have the number of diagonals as 10. Okay, let's do the last problem, that is question number 5. Let E and I denote exterior and interior angle of a n-sided regular polygon. Okay, E and I denote exterior and interior angle of a n-sided regular polygon. Okay, so we know that since the polygon is regular n-sided, we know that E will be 360 degree by n, where small n is the number of sides of the regular polygon, and also I, that is each interior angle, will be equal to 180 degree multiplied by n minus 2 divided by n. Okay, then which of the following is incorrect? Okay, now from this we can clearly see that n is equal to 360 degree by E. So definitely it is the question is asking to select the choice which is giving incorrect information. So we can say this is a correct choice. Choice A says n equals to 360 degree by E, which is a correct equation that or correct relation between n and E, because we know that E is equal to each exterior angle is equal to 360 degree by the number of sides. Okay, what is B? B is saying that I is equal to 180 degree minus E. Now since E and I are the exterior, since the polygon is regular, all the exterior angles will be equal to E and all the interior angles will be equal to I. So definitely we must have, since an exterior angle and its corresponding interior angle, their sum is always equal to 180 degree. So we must have E plus I is equal to 180 degree. So this implies definitely I is equal to 180 degree minus E. So choice B is also a correct statement or an equation. Let's see choice C. C says I into N. So it is IN is equal to 180 degree divided by N minus 2. So this is definitely coming from the relation between each interior angle I and N. Okay. Obviously from here, from this equation, that is I is equal to 180 degree multiplied by N minus 2 divided by N, if we do cross multiplication, clearly we get IN is equal to 180 degree multiplied by N minus 2. So definitely this is also a correct equation. So we are only left A is correct, B is correct, and C is also correct. So definitely the answer has to be choice D, because we are only left with choice D. So let's anyway discuss, see what is choice D. It says that E by I is equal to 1 by N minus 2. Let's find out what will be E by I. So E is 360 degree by N, and I is 180 degree N minus 2 divided by N. If you simplify, it will become 360 degree by N multiplied by N divided by 180 degree N minus 2. Okay. So N cancels out, 180 degree will cancel 360 degree with 2, and this is equal to 2 by N minus 2, and definitely this is not equal to 1 by N minus 2. So hence this is an incorrect equation or statement, and hence the correct choice is D. So this brings to an end in solving another set of 5 good problems. This was set 3. I hope these problems will give you a good practice of relatively harder problems on the chapter of polygons, and this will also evaluate your understanding of the chapter concepts. If this video was beneficial, then please like it, share it with your friends, and once again please support me by subscribing to my channel, and do not forget to press the bell icon so that you will be notified by my future videos. I will come up with more sets of this kind of 5 good problems on this chapter of polygons, so please stay tuned. And very soon also I will start the next chapter, that is quadrilaterals, in the other playlist, that is CBSE Maths 8 R.S. Agarwal. I will end the video here. Thanks for watching, and until the next video, take care and bye.